Today in class, we looked at a couple different odor models from the class, and we reviewed them for how well they represented the properties of gas. For the rest of this video, I'm going to walk you through a model that I made, hoping that you'll find inspiration in it for your own. Welcome to Digital Renderings with Ms. Hunker. I wanted to provide y'all with an example of an odor model that maybe you could use to help guide your own. We looked at a couple models in class today, but I think it's pretty important to have it on the record. So here we go. Enter my creation from canva.com. Here you'll see I have my odor source, which is this rose, and I have demarcated my odor molecules with a pink dot. You'll see that in order to meet the requirement of showing that gas takes the shape of its container and it can enter and exit a container, I have placed my odor source in a glass bottle so you can see the odor molecules emanating from their source, floating up to the top like air molecules do, and then squeezing out into our atmosphere from outside the bottle. I imagine this cork to be pretty tight, so I wanted to limit the amount of visible molecules exiting the bottle in my model. Then I have my different basic air molecules modeled over here. I have nitrogen as blue, I have water as green, I have carbon as brown, carbon dioxide rather, and then at the very bottom I have oxygen as white. So those are the general ingredients of air just about anywhere. Therefore, you'll find a pretty even distribution of those molecules across my entire model. I have a hot environment to the left, and I have a cool environment to the right, but more or less my composition is the same because air is more or less the same as you pass from one place to another, give or take some pollutants, some odors, etc. I've indicated something really important though. At the bottom of my key on the left side, you'll see a zigzag line that's supposed to represent motion. I decided that I didn't want to crowd the image with all of these zigzags, so I just put one in each little segment of my model to indicate the degree at which all of these molecules are moving. You'll notice that the zigzag on the left side, the hot side of the model, is thicker and it's longer and it's just generally bigger because I want the viewer to note that the motion of the molecules on the warm side of my model, even inside the bottle, are moving much faster than the molecules on the cold side of my model, even in the bottle. The zigzags within the bottle also speak to the fact that the hot side of the bottle would have probably more pressure than the cool side because an increase in temperature means an increase in pressure. So the zigzag on the inside left side of the bottle is bigger than the zigzag on the inside of the right side of the bottle because those air molecules are still cool and therefore moving less rapidly. And that's Ms. Hunker's model.